Okay, before we get started with today's lesson, I want you to talk to your group. If you're at home, I guess you can tell, I don't know, your family at some point. Talk to your group about what puts you in a good mood. So what kind of activities, or if somebody else does something, I don't know, could be a lot of things, but what puts you in a good mood? Pause the video, talk about it. So your handout today starts with some vocabulary that we need to talk about polygons. So if you haven't done this already, go ahead and get out your textbook and go through the definitions of each of these things. Some of them, just like an example is going to suffice, like a convex or concave. I think just a few examples, you can tell what's happening with those. That's on page 57 to 59. And you also, I didn't put this on the notes themselves, but you also need to know the names of the polygons by their sides. So knowing, well, 3 sides is triangle, quadrilateral, 5 sides is pentagon, hexagon, heptagon, and all the way up to 12, but not including 11. So it's kind of a weird thing, but usually we know decagon is 10, dodecagon is 12, and then 11 is just not typically one that we write. In your textbook, it does give you 2 options for a couple of them. Like you may have immediately, when you get on here, see trigon. That seems very strange to me. I don't know if I've ever heard somebody refer to a triangle as a trigon. Maybe that's a different culture thing. I don't know, but we're going to call it a triangle. Same thing for 4-sided. We will call it a quadrilateral. Not the tetragon, although we'll talk about tetrahedra later when we have 3D. But anyway, for the 9-sided, we will call it a nonagon instead of an enneagon, although if you follow the Enneagram, it is a 9-sided shape. So that makes some sense that it's called that, but it's more acceptably called a nonagon. That's what it's usually called. Anyway, hendecagon is there, but I don't expect you to know 11. I'm not sure why. It's just not one that is typically used. Anything that is past that 12-sided, we just call whatever number of sides it has gon. So if it has 23 sides, we would call it a 23gon. So we don't need to know names after that. But for your up to 12-sided, not including 11, we do need to know the names because we might be asked, find the perimeter of a regular heptagon, and I would have to know how many sides that is. Or we might have a question where it says to determine the number of sides based on information, or determine what it's called based on the information, and then once we figure out the number of sides, we would have to know what it's called. Okay, so you are writing definitions there, as well as those names of polygons before you join me for the rest of this. So if you need to, pause the video and do that first. I'm going to be jumping down to our basic formulas. I know that there are other formulas there that you have to write. There's triangle and circle. We will have a whole chapter over area next block. So I'm not concerned that we know formulas for everything right now, but the square and the rectangle are just shapes that come up in a lot of word problems. They probably come up more in ACT problems than any other shape, and I would expect us really to know them already, but I want to make sure that we do know them. So for the square, since all of the sides are congruent, so it is equilateral, it is also equiangular, which makes it regular. So it is the regular quadrilateral is a square. Its perimeter is found by taking your 4 sides and multiplying by what that side length is. I know it kind of stings to use an S in a formula. Sometimes it looks like a 5. But we're multiplying 4 times the number of sides. They're all the same. Side plus side plus side plus side. For the area, I am multiplying length times width, but in this case, side times side because they're the same, which would make our area formula side squared. For a rectangle, in our perimeter, it's not equilateral, but we do have 2 sides. Our opposite sides are congruent and parallel to each other. So for our perimeter, we've got 2 lengths plus our 2 widths. And then for the area, our area will be length times width. So if we didn't know those, we've got them written down now. We're going to go ahead and jump into different examples that you might see of finding an area or using using perimeter, which we're going to talk area for these first couple, but the rest are just perimeter. Because again, we'll have a whole chapter over area. So our first two examples, we're finding the perimeter and area just using formulas. So for A, and typically we don't just assume that it is a certain shape, but for everything, well, anything that we're using a formula for today is just going to be a square or a rectangle. We'll see some odder shapes, but we will talk through those. So I do feel like I'm assuming a little bit here because usually we have more properties going on, but this is a rectangle. So to find the perimeter, we've got 2 lengths and 2 widths. So once we have that written down, I just go to your calculator and get 37.4. Since we are talking perimeter, it is just in meters, where for area, my length times width is just 13 times 5.7. .1, and area is in square meters for this example at least. So when we're talking about area, and we'll talk more about this when we get to the area chapter, but we're saying that 74.1 meter by meter squares fit in this rectangle, little meter by meter squares, 74 of them, 0.1. For B, it is a square. We're assuming a little bit it's a square. We've got a side length of 1.6, and so our perimeter is going to be 4 times 1.6. And then for our area, we've got our side squared, technically length times width, but our length and our width are the same. And I got 2.56. So this guy would be in centimeters for your perimeter, and then in centimeters squared for your. On the back, we've got some other types of shapes. So for C, we're finding the perimeter of the polygon here. And in order to find the perimeter, I do need to know how many sides it has. So I'm going to start here. We've got 1, 2, 3, 4, 5, 6, 7, 8 sides. So that makes it an octagon. And because it is equilateral, that means that all of those sides are going to be the same. So I've got, for perimeter, 4 plus 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 4. Or I can take my side length and multiply by the number of sides. Just like for my square, I took the side length and multiplied by 4 because it always has 4 sides. In this case, I can take my length, and multiply by 8 because that is the number of sides. Same thing I would get if I added 4 8 times. Same concept if we are given in words a regular pentagon with a side length of 12 feet. So this is where I'd have to know my vocabulary a little better, because for regular, I would have to know here that this means equiangular and equilateral, which in this case, we're not going to use the equiangular part, but we will use the equilateral part. And then the fact that it's a pentagon, we would have to know that a pentagon has 5 sides. But then we are answering it the same way that we did C, that each of those sides is going to have the same length if it's regular, because it was equilateral. So we've got our length, 12, times the number of sides would give us 60 feet. So then E and F are a little bit different. Yes, they are made up of rectangles or squares, but we're talking perimeter here, not area. So we're looking at making sure we know the length of every side. So we've seen figures like this before. It was in our very first chapter with segments that it would just ask you like the length of one of these sides. So we're using that same concept to begin with. So for E, knowing that this horizontal piece is 12 meters, and then this part is 8 meters. It doesn't have to be to scale, but if that whole thing is 12 and this is 8, that means we've got 4 meters left over for those horizontal pieces that our 4 and 8 have to add up to be 12. Segments going in the same direction, they're going to have the same length. It's kind of the segment addition postulate, but not actually. Same thing for our vertical length over here. If we've got 5 and 6, that means that that full length has to be 11. If it helps you, you could move your 5 over here and say, okay, from here to here is 5, and from here to here is 6. Draw whatever you need to so that we can see those lengths would have to add up to the full length. And now we're finding perimeters, so we are adding up all of these sides. It is not a regular figure, so I don't really have a shortcut. I am adding it all up. Actually, that being said, there's a little bit of a shortcut. We'll see it on the next one. 8, 6, and 4. So I'm getting 46. It stinks when I don't have you guys here to keep me in check. I'm going to try it again. Just make sure 12, 5, 8, 6, and 4. Still getting 46. Okay. So adding up all of our sides. That's what we've got. It might help you to count the number of sides. 1, 2, 3, 4, 5, 6 to make sure that you have 6 numbers because there were 6 sides. It is a hexagon. Okay, so then for F, it is similar in how it's shaped, but you might be thinking that there's not enough information on this one to give the perimeter. And it kind of looks that way, but there actually is enough information. Now, there's not enough information for me to tell what this length is right here, or the other horizontal length, or the vertical length, or this vertical length, but there is enough information to know what they add up to, which is all we need to know. So because this horizontal piece is 14, that means that I know these two will add up to 14 as well. Okay, which makes sense. This plus this would have to equal the whole thing. Same thing for 11. These two vertical segments have to add up to be 11. So kind of a funny thing whenever we have a shape like this that kind of looks like a rectangle that's been caved in on one side. It's kind of a large L, I don't know. A sectional, maybe it looks like a couch. Okay, I'm done. That it actually is going to have the same perimeter as if this was a rectangle this way, because this length is the same length that it would take to fill in right here, and this length, oh, opposite. This length would fill in right here, and this vertical length would fill in right here, and make it a whole rectangle. So my perimeter is really just 2 14s. So I could use the same formula that we used for the perimeter of a rectangle for this shape. Same thing here. I could have used, I've got 12 and 12. You'll have 11 and 11. So we could use the rectangle formula. Now with something like this, I do like us to go ahead and find pieces if we can, because sometimes in other instances that is helpful for us to be able to do. Okay, so we've got, oh, I don't know why I'm typing this in. I could do that in my head. 49. And we didn't have units on this time. So just 49. If you want to put units next to it, just say units. That's fine. Especially when we get to area, we will say units squared, whether we have units there or not. Oh, what did I just do? 28 and 22. Were you guys yelling at me here? This is 50. I said I could do it in my head, and then I wrote down something silly. Okay, well, we'll just go over here. No harm, no foul. Everybody's fine. All right. So some other questions that you could be asked with perimeter that are not just find the perimeter. For G, they tell us the perimeter of this quadrilateral is 33 inches, and then we're finding the value of A. So knowing that perimeter is the sum of all sides, we would take the sum of all of the sides. So our A minus 1, A plus 3, 3A minus 3, and 2A minus 8. And we know that the sum of all 4 of those sides has to equal 33. So kind of a lengthy equation, but lots of like terms that we can combine. For our A's, we've got a 1A, and A is 2, and then 3A is 5, and 2A 7. And then for our numbers, we might notice we've got a 3 minus 3. That's helpful. 3 minus 3 is 0. So we're just left with a -1 and a -8. if you weren't catching all that, you might go back and go through that more slowly. But I believe we should have a 7a minus 9. And then whenever we add 9 to the other side, we've got 42. Dividing by 7, we get that a is 6. Okay. For h, we're given the perimeter of a square, and we are finding its area. Okay, so remember, for a square, it only has one dimension. It just has a side length, and that is the side length for all of it. So if I'm going from perimeter to area or area to perimeter, I want to find that side first. So using the fact that perimeter is 4 times a side length, I'm going to use x as my side, if that's all right. My perimeter is equal to 68, so that's saying that we multiplied the side by 4 to get 68. So I can divide by 4 to get what that side length is. We've got 17 as a side length. And now I'm ready to find the area is a side squared. So I've got 17 squared, which is 289 yards squared. If we were going back the other direction, so if it gave me the area and I was looking for the perimeter, remember that area is your side squared. So once you set it equal to that area, you would have to take the square root of both sides to get a side. Okay. And then the last one, we've got the Polygonensteins built a rectangular pool that's 30 by 40. They want to put a 4-foot wide walkway around the whole pool, but they're not sure if there's enough space for it. What area will the pool and the walkway take up? Okay. So first, a picture. What this is talking about, they've got this pool. This is not to scale. That is 40 by 30. And then they have a 4-foot wide walkway that is going around the whole pool. So anytime you hear something described like this, it's saying that 4 feet, I'm going to use a different color, that 4 feet is happening all the way around it. So you've got 4 there, and 4 there, and 4 there. That pin did not even make it around my pool. Okay, so if I'm looking at the area of the pool and the walkway, I need to know what my new side length, my new width, and my new length are going to be. Ran out of space. So if my original width is 30, now I've got this walkway on both sides. So I've got a 30 plus 4 and then plus 4. So now I've got 38 as my pool and width on both, and walkway on both sides. Same thing for my length. I had 40 as my pool, but then I added walkway on both sides, so I've got 48 as my length. And now we're ready to find the area using just length times width, so my 48 times 38 is area, so it is squared. And that's all the information that we have, so I hope their pool is going to fit. If not, I guess they could make a smaller walkway or not have a walkway. I don't know. Go Polygons. Okay, so now you all are trying the polygon sequence. If you get stuck, well, first I would try it. That's the first thing. Sometimes we throw our hands up at the very beginning. It could be an example like one of these, and so maybe you go back in the video and rewatch that part. But there are a few that are challenging, so if you're stuck, I would talk to the people in your group. And then for today, since I'm gone, talk to the substitute. She does have a key for this, so she might be able to give you some hints on where to start. The very last one actually does have a hint below it, but if you can do it without the hint, work it without the hint. All right. Hope you all have a great day.